Hello dear learners, I am Dr. Vandana Yadav, Assistant Professor, Faculty of Science, the Bhopal School of Social Sciences, and today I am here to discuss another important topic, that is stability of cycloalkanes, that is Baeyer strain theory. In this we are going to study introduction, assumptions, postulates, limitations and conclusion. Now, what is Baeyer strain theory, or what are the assumptions which were used to design Baeyer strain theory? So, let's start with Baeyer strain theory. Baeyer in the year 1885 proposed this theory on the basis of Van 't Hoff theory and Labelle theory. Now, first understand what was Labelle and Van 't Hoff theory. According to Labelle and Van 't Hoff, carbon having 4 valency, I'll show you in the diagram. All the 4 valencies of carbon are directed in the 4 corners of tetrahedron, as you can see in the diagram, and the angle between them is what is 109 degree and 28 minutes. So this angle is called the normal tetrahedral angle. Now, Baeyer on this basis postulated that any deviation of bond angle from this normal tetrahedral angle of 109 degree and 28 minutes will impose a condition of internal strain, and this strain was defined as angle strain. So you can see that if my hand is in the straight position, then you can consider it the normal open chain structure, but when I am trying to construct the ring, then this ring means when I am folding my hand, it is experiencing some kind of strain, and that strain is defined as angle strain. So angle strain determines the stability of the ring. So therefore, Baeyer strain theory is related to stability of cycloalkane rings. Now coming on to assumptions of Baeyer strain theory. So assumptions of Baeyer strain theory. First assumption of Baeyer strain was that all the rings are considered to be planar. So all the rings are planar. You can say that all the carbon atom which are constituted in the ring, they are lying in the same plane. So hence what we can say, hence in this condition, as you can see in the diagram, that when I have constructed a ring structure from an open chain structure, then this ring is no longer having an angle of 109 degree 28 minutes, but instead now the angle is reduced to 60 degree, and different rings can have different value of this angle. This is a special example of cyclopropane ring. So this was the assumption made by Baeyer strain theory, based on which he gave different postulates. So let's discuss the postulates. First postulate was that any deviation, any deviation, that means either the positive or the negative, any deviation from this bond angle, that is 109 degree 28 minutes, when you are having open chain and you are constructing a ring. So during the construction of this ring, if there is deviation from your normal tetrahedral angle, then this creates a strain in the molecule, and which is one of the reasons of instability caused in the molecule. Now, larger the value of this deviation from the normal angle, and greater will be the strain, thus the stability will decrease in the same order. Sign of deviation I'll show you this, that sign of deviation do not make any difference. You have to consider what? You have to consider the value. How much deviation is there from the normal tetrahedral angle. And another postulate was that you can construct a ring with 3 carbon, you can construct a ring with 30 carbon. Okay, all do exist, but they are strained due to bending or distortion, or you can say steric interaction. So there can be bending, there can be distortion, and there can be steric interaction. So these were the 3 postulates made by Baeyer, and these postulates were then further explained by using simple formula, that in order to calculate the deviation, we have the formula T is equal to half into 109.5 minus alpha. And what is alpha? Alpha is the bond angle when you are constructing cycloalkane. So let's have a look at the different examples. First, as I have already shown you, this is your cyclopropane, and the angle of deviation is 60 degree, and hence we calculated the strain, which comes out to be around 24 degree 44 minutes. Then cyclobutane, this is the structure, and you know the angle is 90 degree, and this is the angle strain. Similarly, you have cyclopentane, angle is 108 degree, and you can see that deviation is, or angle strain is reduced. Further, the cyclohexane, I am drawing the structure, angle is 120 and it is negative value 5 degree 16 minutes. Similarly, heptane is 9 degree 33 minutes and octane is 134 degree and angle strain is 14 degree and 46 minutes. So in short, what we can say is that it is the ideal bond angle of alkane compound that produces maximum bond strength and stable molecules. When you don't have this ideal angle, then stability decreases. That is, we are moving toward unstable condition. So you can have a look at the structure. I have already shown you this. But there are certain limitations of Baeyer strain theory, because as you have seen in the table, that when we are moving from cyclopropane, then to butane, then to pentane, there was decrease in the angle strain. Okay, and that means there was deviation from ideal angle, and higher the strain, higher is the instability, or you can say there is increased reactivity, which leads to increased heat of combustion. But Baeyer strain theory had certain limitations. First one was that though it explained the deviation, but it was not able to explain the effect of ring strain in larger rings. Larger rings means like hexane, or you can say with 7 carbon or 8 carbon. Okay, and according to Baeyer, cyclopentane should be much stable than cyclohexane because there was less amount of angle strain. But practically you will see that it is not there. That means it is, the condition is reverse. So limitation was that larger ring systems are not possible according to Baeyer. Why? Because as you have seen in the table that the strain in them was negative, but you know that these higher rings do exist and they do react. So Baeyer's theory was not successfully applicable to larger ring system, and the reason was that Baeyer considered ring system to be planar, but the larger ring systems are what? They are not planar. But here comes a new word, that they are puckered. Puckered means you can say they are somewhat wrinkled. to eliminate maximum angle strain. So therefore, due to these limitations, we can say that Baeyer strain theory is only and only applicable for smaller ring structures. So thus what we can conclude from all these assumptions is that cyclohexane and higher cycloalkanes should become increasingly unstable and hence they are more reactive. But instead of this, what we observe that they are comparatively more stable, and instead of undergoing addition reaction, they basically undergo substitution reaction. Thus, this theory satisfactorily explained only 3 cycloalkanes, that is your cyclopropane, cyclobutane and cyclopentane, but it is not valid for cyclohexane and higher member ring. And reason I already told you that they are not planar, but Baeyer considered all of them to be planar. So according to Baeyer, the relative strength of your first three cycloalkanes is this, and for the cyclohexane like 6 carbon, 7 carbon or 8 carbon, we cannot apply Baeyer strain theory due to their negative angle strain, and also they are not planar in their structure. So Baeyer successfully explained the stability of cyclopropane, cyclobutane and cyclopentane, but it failed in the case of higher cycloalkanes. So thus what we can conclude is that cyclopropane, cyclobutane and cyclopentane, they experience angle strain, and that angle strain is responsible for their stability. And finally, you should remember that any deviation from the normal tetrahedral angle will lead to angle strain, and higher the value of angle strain, higher will be the instability and higher will be their reactivity. So in simply, higher the deviation, lesser is the stability. So that is all from my side in this topic. I hope you all have clear understanding about the Baeyer strain theory and the stability of cycloalkanes. Thank you. Keep watching our channel.